Hello, my name is Mukul Mohan. The title of my research paper is Study of Effect of Solar Activity on Magnetospheres during Ascending Phase of Solar Cycle 25. A sun spot is a dark patch on the surface of Sun. It is made of two parts, umbra and penumbra. The inner part is called umbra and the outer part is called penumbra. On the basis of Zeeman effect, Halley proved that sunspots are magnetic in nature. In Babcock Lengthen picture, sunspots form due to coupling of differential rotational motion and polar magnetic field of the Sun. The lives of sunspots vary from few days to few months. The number of sunspots become maximum to minimum and back minimum to maximum on the surface of Sun. This cycle is known as solar cycle. इसमें वीडियो थी.
सोलर साइकिल का पीरियड कितना होता है? हेलो,
एक्सक्यूज मी,
सोलर साइकिल का पीरियड कितना होता है?
11 years average. A CME is an average explosion of bubbles of plasma from the surface of Sun. We have collected the data from different data centers like Royal Observatory of Belgium, WDC Kyoto, Japan. On the basis of the DST index, we have classified geomagnetic storms into three categories: moderate, intense, and severe geomagnetic storms. This is our data of sunspot number, geomagnetic storms, and LOCME during 2019 to 2025. Sorry, 24. In the diagrams, we have compared sunspot number, geomagnetic storms, and LOCME along the phase of the solar cycle. This is geomagnetic activity observed in month of April. The downward peak in the last panel represents a geomagnetic storm. An intense geomagnetic storm was recorded during this period. Similarly, an intense geomagnetic storm was observed in month of May. In month of October, an intense and severe geomagnetic storm was recorded. LOCME followed the phase of solar cycle, but geomagnetic storms did not follow the phase of solar cycle. Large values of electric field were observed before few hours of geomagnetic storms, and large values of interplanetary magnetic field were observed before geomagnetic storms. Thank you.
next is Arun Kumar Sharma. Will be available?
Arun Kumar Sharma is here. So next,
Bhupender Kumar,
Upendra Kumar is here. Next,
Deepak,
दीपक
Next one.
Good evening, everyone. Respected guests, esteemed faculty, and fellow researchers. My name is Deepak, and I am working as assistant professor in Department of Physics, Lajpat Rai College, Hyderabad. Now I will present my oral presentation based on the topic of impact of optic propagation on solvent to magnetize inhomogeneous alkyl plasma with negatively charged dust. Non-linear waves play a crucial role in solution dynamics, both astrophysical or laboratory plasma. Among the non-linear wave solutants specifically importance because they arises the balance between the non-linearity and dispersion. When the non-linearity stiffening is balanced by the dispersion spreading is a stable localized wave are formed which travel over a long distance without change its shape and it can be used as a energy transportation because its shape are not distributed over a large distance. Here in this plasma model we consider a magnetized inhomogeneous plasma where external uniform magnetic field is applied along the z direction and the solidum is assumed to be propagated in xz plane where the xz plane and the angle with respect to magnetic field. So in this plasma we have multiple particles. In this model, electron and proton are assumed to be moving particles and ions and thus as they are heavy, so they assumed to be stationary. So here we write the dynamics of charged particles, continuity equation, momentum equation, and next we write Poisson equation. So we study the non-linear, so we study the solution. So to describe the solution, we use the reductive perturbation technique. In this technique, we expand the density, velocity, and electrostatic flux in terms of the smallest parameter, which is the strength of the perturbation. And now we use the space coordinate system where the solution where the time and space. This is the expression for the time and space variation of solution. And when we analyze the first order equation, we find the phase velocity relation lambda equals to phase velocity relation is defined this relation where h is the electron to positron density equilibrium density ratio, sigma is the positron to electron temperature ratio, and dt theta is the directional velocities. And when we move in further, we solve the first order equation and second order equation, and eliminating higher order equation, we get the modified KdV equation where alpha is the non-linearity coefficient, beta is the dispersive coefficient, and gamma is the inhomogeneity constant. And this is the last term is actually appear for the inhomogeneity of the plasma. And we have to express this solution. So we find solution of this modified equation by the method of Young, and the solution is Vx equals to V naught set hyperbolic square x1 where V naught is the amplitude of solution which will depend on non-linearity coefficient, and W is the width of this solution which is depend on dispersive coefficient beta. Now we move further to result, and the first plot show the variation of phase velocity of solution with propagation angle for
Please conclude.
Okay, with different propagation angle. And second is the same phase velocity relation but different electronic temperature also. And third is the width of this soliton with propagation angle. Width of soliton is increased with the propagation angle as the width is directly proportional to dispersion coefficient, and dispersion coefficient is directly proportional to propagation angle. And this is the plot of the width versus magnetic field. As we increase the magnetic field, width of solution is decreases, and this is the plot of amplitude versus propagation angle for different dust density. And this is the final stage of solution profile with different propagation angle. This is the conclusion of the presentations.
Thank you.
Thank you.
MKD की फुल फॉर्म बता दो।
Modified KDE.
इस KD
अच्छा, कोड बेस डी वेरिएबल